This is a short tutorial on how to use Science Express's ICP kit, Exploring Atoms. Alright, so this is the general layout for the first day of the kit. This would be like a typical station that a student might have set up for them. So we've got protons represented by these green marbles here. We've got neutrons represented by these yellow marbles. We've got electrons represented as cotton balls. These you'll have to supply for yourself. These will be included in the kit. We also have a layout for what the atom will be like. So for smaller atoms like hydrogen, we have this yellow sheet. Atomic nucleus is in the center, and you've got a small petri dish to hold your protons and neutrons. You've also got the electron cloud around the outside where you can place your electrons. We've also got a larger atom, so you can have kind of the larger electron clouds as you step into the second period of the periodic table, getting into atoms like fluorine, so you can hold kind of more stuff around here. Your instruction sheet will kind of lay out what your students will need to do and also guide you on what questions you might want to ask. But of course, feel free to change this to fit your classroom. This kit is designed to bridge from the atomic structure that you may have already covered in your class into bonding. So you might pick and choose just the atomic structure part to use when you introduce that. You might cut out some of the introductory material if you are going deeper into bonding than this kit would show. But hopefully this gives you a good springboard into what you need to do. So generally how the kit will work is you will have your students making atomic models using the protons, neutrons, and electrons just by placing in marbles to show the number of protons and neutrons and electrons that might be in a model. So a model of hydrogen 2 might look something like this, where you've got one proton, one neutron, and one electron. This might help with students to kind of see your mass number, having your number of protons and neutrons together, but you still only have one proton, meaning this is just hydrogen. You have one valence electron, which you can kind of use to bridge into bonding later. You may also use this to talk about average atomic mass, comparing a model that one student makes to a model of another that has differing number of neutrons, averaging those out with how common those isotopes are, as well as with the mass of the isotope can kind of show you how you get those strange numbers, those decimal numbers on your periodic table. For larger atoms, again, we've got this blue sheet here where you can place more protons. So if we wanted to make 1, 2, 3, 4, 5, 6, an atom of carbon, we could have 6 protons. If we wanted to make it carbon 12, we could have 6 neutrons to go along with it. 1, 2, 3, 4, 5, 6. And we could also show it's 4 valence electrons. 1, 2, 3, 4. The kit should have enough marbles and sheets to supply 12 groups. There should be enough marbles so that you can make the models that this requests. So if you have multiple models going at the same time, you should have enough. Based on how your lab tables are set up, you might want to put some white paper in the background of these transparent sheets. That way there's less glare. You can see your students' atoms models at a glance a little bit easier if you're walking around the room. And it might also be easier for them to kind of see stuff as they're setting things out. Along with the instructions for the kit, the packet holding the instructions also has an at-a-glance list of what each station could use. So if you're trying to set this out kind of in a hurry, or if you want to get this done before you leave school or something like that, you've got a kind of quick list of what each station will need to kind of help you out. If you would like to connect this to covalent bonding between atoms, this is where the transparent nature of these sheets comes in handy. We can overlap these pretty easily to show how our electron cloud can be shared between atoms, especially looking at the number of valence electrons that are shared in that crossover. So if we were to look at 2 atoms, say a small atom like hydrogen and a larger one like oxygen, if we set out their valence electrons, hydrogen's 1 and oxygens 1, 2, 3, 4, 5, 6. We can share those electrons in this overlapped region to represent that covalent bond. You can then go kind of show the extent of this, maybe with the octet rule, if you'd like to connect to that. Put in another atom of hydrogen. Share another electron here, another hydrogen, to make a water molecule. Right? So we can show how these valence electrons are shared between these atoms. You can show the extent of bonding, you could talk about molecular shape. You can take this in really any direction you would like to. We supply enough materials for up to 4 small atoms for every large atom. So you can get into molecules of CH4, or you could do NH3, things like that. The icing on the cake for this kit are these SNATOS models. They're great at showing how atoms may bond covalently, quickly, with magnets, while still reflecting the correct molecular shape. This can help if you would like to show why some bonds do not go across, might go at stranger angles, like for this water molecule. You can make all the different molecules that we cover in this kit, and you might even encourage your students to try making other molecules based on the number of valence electrons that you can share in these covalent bonds. We supply 3 packages of these SNATOM kits in your ICP kit, so you have plenty of SNATOMs to work with across your different groups. So each group should be able to make enough models that are required for the kit, and you can also extend this to whatever you'd like to use for your classroom.